ሰላም ተማሪዎች እንደምን አላችሁ? እኔው ነኝ የ10ኛ ክፍል የፊዚክስ መምህራችሁ። ዛሬ የምንማረው ዩኒት 1 ቬክተር ኳንቲቲ ስካላር ኤንድ ቬክተር ኳንቲቲስ ይሆናል ማለት ነው። ስካላር ኤንድ ቬክተር ኳንቲቲስ what are ስካላር ኤንድ ቬክተር ኳንቲቲ? ዌብሳይታችንን lucybridgeacademy.com በመግባት የተለያዩ ሾርት ኖቶችን የተለያዩ የጥያቄ ባንኮችን እንዲሁም ከ5 በላይ ቋንቋ መረዳት የሚችል የኤአይ መተግበሪያ ፕላትፎርምን እናም ዩቲዩብ ቻናላችንን ሰብስክራይብ በማድረግ ሐሳብ አስተያየታችሁን እንድትሰጡንና በተጨማሪም የቴሌግራም ቻናላችንን ጆይን በማድረግ ሐሳብ አስተያየታችሁን እየሰጣችሁ እንድትቆዩ ስንል እንጠይቃለን። እናመሰግናለን። አሁን ወደ ትምህርታችን ምንድነው የሚያካትተው ምንድነው የሚለውን ነገር ወይም ደግሞ መሰረታዊ ነጥቦች ምን ናቸው የሚለውን ነገር አብረን የምናየው ይሆናል ማለት ነው። ስለዚህ let's start our lesson. Okay? Be careful and be patient and try to focus on the video, please. So by having this, let's start with the definition of scalar and vector quantities. Scalar and vector quantities. What are scalar quantities first? With that of the scalar and vector quantities which can be classified as what? Quantities which can classify as the scalar and vector quantities. Okay, quantities which can be classified as scalar and vector quantities. This scalar and vector quantities which can be classified having that of their magnitude and dimension which depends to be measured on a given quantity. So by having this, the first one is the scalar quantity. The scalar quantities are quantities or physical quantities which are fully or totally have only magnitude. They have only magnitude or described by having that a single number having an appropriate unit. So these scalars are commonly like that of mass. For example, mass. When we say mass, around that of 12.21 kilogram meant by the quantity which is measured having that of what? 12.21 in number and the kilogram, that is the scale that we use to measure the quantity. The scale that we use to measure the quantity. And length, which has a SI unit meter and also non-SI units like that of centimeter, kilometer, decimeter, and hectometer, and any other miles, and also that of the very long distance measurement like that of the astronomical object, between that of the astronomical objects like astronomical units like that of the light year, and also there are different measurement in millions of kilometers. This is because of what? The celestial bodies or astronomical objects which are very far to each other. Then by having this like that of the light year, when we define light year, that is measured having that of 9.46 times 10 raised to 12 kilometer. This is having that of what? The light year which measures what? The amount of distance a given light travels in a given year, in 1 year. Light travels in 1 year. In such a way, we can measure what? The distance of a given point or the distance of a given celestial object, or it is also called what? Length. So in such a way, for example, here the length which is measured having that what? 1.42 meter. 1.42 meter. When we have 1.42 meter here, that's 1.42, which is what? 1.42, which is 1.42 is the quantity or the number, whereas the meter is what? The unit of measurement. And density, that is like that of the density of water, and that of the scalar density of water, which is around what? 1000 kilogram per cubic meter, or it is 1 gram per centimeter cube. You will have this in that of the fluid statics. You will have this in fluid statics. So by having this, let's give some common examples of what? Common examples of the scalar quantities, such as what? Time, which is a scalar quantity. With that time like that of the time t in second, or other non-SI like minute, hour, day, week, month, year. Okay? The second, which is what? The SI unit. Whereas non-SI units. Non-SI units. The SI unit. The SI unit. Here, non-SI unit. Non-SI unit. Such as what? Minute, hour, day, week, year or months. Okay? Months, year, and so on. And so, okay? Like that of year, decade, millennium, century, and so on. And so on. So by having this, you have what? That are a time measurement, which is a scalar quantities. Whereas distance, here, the distance or length, which describe in what? Which can be has an SI unit in meter. And the non-SI units, which is like that of kilometer, centimeter, decimeter, micrometer, and so on. Light year, astronomical unit, astronomical unit, and so on. Okay? And so on, etc. We have different units which can be measured having that of what? The scalar and vector quantities. But in that of the scalar quantity, like that of distance, which is measured in that of what? Meter, by having that of its SI unit. Whereas an NSI unit, like that of this, the speed, with that of the speedometer, the speed V, which is in what? Meter per second. Here in NSI unit, like that of kilometer per hour. Okay, kilometer per hour. And the other NSI unit, kilometer per minute. Kilometer per minute. Mile per second. Mile per second. And so on. And so on. The temperature, which has the SI unit, the temperature, which has an SI unit using that of what? Kelvin, which is measured in Kelvin. And an SI unit like that of degree Celsius, degree Fahrenheit, and so on. Whereas that of energy, which has the energy which is measured in that of what? Joule by the name of what? The physicist, the industrial physicist, whose name is what? James Pascal Joule. Here, Joule. Then after, non-SI unit like that of Newton meter. Okay? And also calories. The energy of food, which is measured by having that of what? Calories. So in such way, we can determine these scalar quantities. Whereas in that of the vector quantities, when we call vector quantities, are the quantities which describes both magnitude and what? Direction completely. To have what? Their quantity to be measured. The quantity which can be described by both magnitude and direction. For example, in that of the velocity. Here, the velocity, which has what? The speed with direction. Speed with direction. The speed of an object in a given specific direction, which is described as what? Velocity. The distance in which in specific direction we call it is a displacement. So by having this, a vector like velocity, only meaningful when the both speed and direction are what? Specified, like that of 100 km per hour north. Okay? Or here, 10 meters per second due south. Okay? The velocity which is the same as what? 10 meters per second due south. In such a way, we can define vector quantities. Some common vector quantities, other than what? The scalar quantities. Other than scalar quantities, like the velocity. V, again in meter per second, which has an SI unit like that of what? Kilometer per hour, and any other. The same SI unit as what? Speed. The force, which is in Newton. Then after has an other SI unit like that of kilonewton. Okay? And also the another non-SI units. Here it is, non-SI units. Here it is, SI units. The SI units. Here, the SI units, the velocity, meters per second, like that of speed. The force, Newton. NSI unit, kilometer per hour, like that of the speed. And here the force, kilonewton, kilogram meter per second square, kilogram meter per second square, and so on. And so the displacement like that of distance, but it is differentiated with an arrow. Here it is meter, and here we have what? Kilometer, centimeter, decimeter, and so on. Acceleration, the acceleration having that of meter per second square, meter per second square. Then the same thing that we have what? Kilometer per hour square, kilometer per hour square, or mile per minute square, mile per minute square, mile per minute square, and so on. Whereas in momentum, P with an arrow, which is kilogram meter per second, kilogram meter per second, which has another NSI unit, like that of Newton per second. Okay? Sorry, Newton second. The momentum P, which is the same as what? Kilogram meter per second, as NSI unit like that of what? Newton second. Newton second. And impulse, the same unit as momentum, impulse I, which is kilogram meter per second, which is the same as what? Change in momentum, that the impulse is also the same as the change in momentum. When we change what? The momentum of your body. We change the momentum of your body. The same unit as momentum. The same unit as momentum. Okay? So by having this, such quantities are also called what? Vector quantities. Vector quantities. So you can give a brief classification of what? Scalars and vectors, having that of giving different examples. So with that of the comparison or the relationship with that of the scalar and the vectors. Here, scalars have only magnitude, while vectors have what? Both magnitude and direction. Scalars have only what? Magnitude, while vector have both magnitude and direction. Okay, that's why we call scalars are the quantities which have only magnitude, but vectors are a quantity which have both magnitude and direction to describe a given quantity. Whereas a scalar describes quantity like what? Mass, temperature, time, volume, density, amount of substance, temperature, and so on. Whereas vectors, which can be described like that of what? Like that of displacement, velocity, acceleration, force, momentum, impulse, and acceleration, and so on. So with that, by differentiating or recognizing either the given quantity are scalar and vector, it is essential to solve what? It's essential to solve the real life problems in our world or in our surrounding, having that of the physical problems. To determine the natural phenomena to the relationship of what? Matter and energy. So by having this, you can determine how we can differentiate the physical phenomena in nature by having that of what? By differentiating the scalar and vector quantities. So on the next video, just please try to do these questions carefully, and we'll do it together. Either you can do it individually or what? With your partners. Then on the next video, we'll discuss about what? The vector representation. How we can represent vector. Then at the end of this lesson, or at the end of this video, you have to be able to identify the magnitude and direction of vectors, and also you have to represent, and now how to represent what? Vectors. And we will discuss some point about what? The types of vectors. እስከዛው ድረስ ግን እንደ ሁሉ ጊዜው መርሳት የሌለብን የሉሲ ብሪጅ አካዳሚ ዌብሳይታችንን lucybridgeacademy.com በመግባት አጫጭር ሾርት ኖቶች፣ የተለያዩ ጥያቄዎች እንዲሁም ከአምስት በላይ ቋንቋ መረዳት የሚችል የኤአይ መተግበሪያ ፕላትፎርም እና የዩቲዩብ ቻናላችንን ሰብስክራይብ እያደረጋችሁ እናም የቴሌግራም ቻናላችንን እየተቀላቀላችሁ ሐሳብ አስተያየታችሁን እንድትሰጡ ስንል እንጠይቃለን። እናመሰግናለን።